5, Brooke? 5 times 50 is?
250.
250. And then when you distribute 5 times 2, you get 10. And 250 plus 10 is?
260.
260. So that's one way. Did anybody do it a different way for the problem? How'd you do it, Taisha?
Just typed it in my calculator.
Sure. You can just type it in your calculator. That works too, right? Did anybody add 50 plus 2 together first and take 5 times 52? You still get 260? Yes, you did that as well? And it's right. Yeah. So you still get 260. You can add the two numbers together first and get 260 that way. Just kind of depends on how you want to approach the problem. The second one, 18 plus negative 25 is the same thing as saying 18 minus 25. Just depends on how you're looking at it. So what is 18 plus negative 25? Brooke?
Negative 7.
Negative 7. All right, the last one, a temperature problem. We want the difference between a daily low temperature of negative 5 and a high temperature of 18. Seems like it's February at this point. January, February. What's the difference between if I start the temperature at negative 5 and we go up to a temperature of 85 or 18 degrees?
13 degrees.
So Jacob says 13 degrees. Anybody else have a different? Brooke, what do you say?
Negative 23.
Negative 23 degrees. Anyone else? Zach. 23 degrees. All right, so we have a couple of different options here. I'm going to draw a little thermometer. Here's 0 on my thermometer. So if you have a thermometer outside somewhere maybe, and it's measuring that it starts at negative 5 degrees, and then it goes up to 18 degrees. So my thermometer is starting to negative 5, the day warms, and probably at about like 4 o'clock in the afternoon it gets to 18 degrees. How much distance is between negative 5 and 18 degrees? 23. So it's a 23 degree difference. And that's because going up from negative 5 to 0, you're already going up 5 degrees to get to 0, and then we go up another 18 degrees more. So actually it's a 23 degree difference. If you start at 18, difference means subtract negative 5. That's how you algebraically would show that you got 23. Sometimes a picture helps to kind of see what's going on. Questions? So make sure you correct that one. We get 23 degrees if I'm starting at negative 5 and digging our way up to 18. Maybe we don't have any cold days like that this year.
Hopefully, so we have delays.
Oh, yeah, Mr. Long likes the delays. Yeah, we
Yeah,
could have
cancellations are bad. Delays are good. Notes a little bit too.
Oh, yep, there you go. You can take it out. Go for it, do whatever.
Yes. All right, real numbers and the subsets. So the notes, we do have a notebook quiz kind of at the end of the chapter, so make sure that you're writing down what we're writing down here on the board so that you can do well on the notebook quizzes.
Anybody not get the sheet that came around for she's in the middle right there. Here we go.
All right, our first little subset of our real numbers would be rational. He had a pass, Miss King.
Okay.
And rational numbers are numbers that can be fractions. So a rational number would be 0.75. What is 0.75 as a fraction? IJ, go ahead. 3/4. That is a good example of a rational number. Another rational number would be 0.3 repeating, which is 1/3. Next one. We call these integers. Wow. Any positive or negative number for integers, no fractions. So your integers could be -1, 1, 3, 4. What's another subset of real numbers? Who knows?
It's more basic than an integer. Like, what other numbers could there be? Yeah.
Oh, good job. And what is a whole number?
Number. Just a number.
Yeah, just a number, but greater than 0. Okay, so any positive, just positive number. And you can count 0. So 0, 1, 4. And our last one, related to rational numbers, will be irrational numbers. And irrational numbers cannot be fractions. So the square root of 2, if you would put the square root of 2 in your calculator, you would have some weird decimal number, okay? Another irrational number is pi. What's the fraction form of pi? Shane, right? What's pi as a fraction, Shane?
No,
You're right.
He means decimal.
Oh, my bad. Decimal. Good, thanks. Sorry. 3.14. Good. Good on irrational numbers?
So those are all the numbers we'll work with this year, rational, irrational. They're all real numbers.
All right. And here we have a number lines, and you're going to work with some number lines for homework tonight. Okay? It's just numbers from left to right here. Who knows what is another name for 0 on a number line? What else can we call 0 on our number line? It's the origin, okay? Yeah. It's 0 on the number line.
Where else would you find the word, the origin? Like what else has an origin in that? Yeah, the graph. Yeah, plot, the graph. So it always starts in the origin in the middle as well.
And a coordinate is just a number corresponds to a point on a number line. See a coordinate written like that. All right. Is this what you see next? Example 1?
Yeah.
Yeah?
Mhm.
All right. It says graph the real numbers, -5/3, the square root of 2, and 2.6. So we have a fraction, we have a decimal here, and then the square root. To graph these numbers, I think the easiest thing to do is what would you do? What would you do? What's one thing that you could do? Go ahead, bro.
Put them all in decimal form.
Yeah, put them in decimal form. So if you have your calculator out, which would be a good idea during class to have your calculator out with you, what is -5/3 in decimal form? Good, Brookie. Yep.
-1.6 repeated.
That's the
Nice. And square root of 2 in decimal form.
1.4.
1.4.
4.
And then we have 2.6 already in decimal form. Okay, so we're just going to graph these real numbers on our number line here. Right, question? You're good? Okay. I was thinking raising your hand too. -1.6 repeating, so we're going to find -1 on our number line. And -1.6 repeating is going to be just right in the middle between -1 and -2. Going over to 1.4. Going to 1 on our number line. And pretty much right in the middle between 1 and 2 is 1.4. And we're also just going to label our coordinates real quick right above the number line. 1.4 and then 2.6. Find 2, a little bit past the halfway mark between 2 and 3, and then we have our coordinate of 2 and 6. Example 2, graph the real numbers -1 and -4. Then compare using the symbols less than or greater than. Okay, so let's graph the real numbers -1 and -4 first. We have our origin here at 0, graphing -1 first. Okay, draw your coordinate right on -1. Going over to -4, to the left, -4, drawing our second coordinate. So we have the coordinate -1 and -4. The second part of the question, using the symbol less than or greater than. So kind of using the number line to help you. What number is larger, -1 or -4? What do you think, Lo? -1. -1 is greater than -4. Questions? All right, example 3. The table shows the record low temperatures for 5 months at the South Pole. Use a number line to order the temperatures from lowest to greatest. Oh no.
No, I think it, yeah, right there.
Alright, so right now, what we can do until the smartboard works, try to put these 5 numbers in lowest to highest, right below your little graph right there, and then we'll graph on the number line. So go ahead, take a minute and try to graph, or just order those numbers right there.
Still not working.
Yeah, it's good now. Okay, so what's our lowest temperature to begin with? Go ahead, Lug.
Negative 117.
Nice. What's next, Lug?
Negative 113.
Good. Next.
Negative 111.
Good.
Negative 109.
All right. So down to our number line, because we have to graph these coordinates on our number line too. So what I'm going to start with is, since negative 117 is the coldest temperature or the lowest temp, I'm just going to start right there with negative 117. And we're pretty much bunched up and close to order, so let's just count by ones. Negative 115, negative 114, negative 113, negative 112, negative 111, negative 110, negative 109. We'll call that last one negative 108. Alright, graphing our first temperature, negative 117. Draw your coordinate, maybe cross it off so you know you graphed it. Negative 113 is our next coordinate. Negative 111 is our third. Going over to negative 109. And then our last one at negative 108, which we had to kind of draw in there because we ran out of space. But that's totally fine if you have to do that.
It's weird.
Yeah,
You can write on it but can't move.
The MacBook works better. Okay, 2 little vocabulary words at the bottom of page 2. We have the opposite and the opposite is, let's just say, okay, let's use an example. We have the number 3. What is opposite of the number 3? Zach, you know? Good. Just negative 3. Just the number opposite of positive or negative. Reciprocal. Let's use the fraction 1/4. Bill, what's the reciprocal of 1/4?
Before 1.
Nice, yes. So think of reciprocal as just flip. Flip the recip. Write that little note. Good questions? All right. 4 little problems on page 5, I think it is. Starting with example 4.
I wonder if the calibration is like.
Yeah, I think that's what it might be anyway. have find a difference of 4 and negative 9. So what does difference mean in math? What do we do?
Subtraction.
Yeah, subtraction. Okay, so we're gonna have 4 minus a negative 9. Alyssa, what is 4 minus negative 9? So anytime you have a subtraction followed by a negative number, it actually turns into addition. So listen, 4 plus 9 gives us 13. C. Also, find a difference of 3 and negative 6. So we have 3 minus negative 6. Keith, what is 3 minus negative 6? 9. Nice job. Or 3 plus 6. B. Find a quotient of negative 15 and 1/3. What does quotient mean in math, Denise?
Huh?
What does quotient mean in math? Divide. Alright, so we're actually going to have negative 15 divided by 1/3. You can't divide by a fraction. Okay? So when you see this, we're just going to go negative 15 times 3 over 1. Reciprocal. Zach, what is negative 15 times 3? Nice. D, very similar. We have negative 20. Find the quotient of negative 20 and 1/4. So negative 20 divided by 1/4, or negative 20 times 4 gives us, Jamie, negative 20 times 4.
Negative
Good job. All right. You can put your notes away, or you might want to use them a little bit for homework, and Miss Kane's going to explain some of the homework real quick.
So if you take out your book and turn to page 6, on the sideboard, your homework is always listed. You also have an assignment sheet that you'll get every week that has the homework listed. So 2 places to look, on the sideboard or on your assignment sheet. Either one will have the homework. There we go. So we're going to start at number 21, and some of these first ones are pretty quick, but at the top of your page, page 6 and 7, 21 to 29 odd, and again it's on the sideboard. Mr. Long is passing out paper for you with number lines on it. 33, 35, 36, and 38, and then the
You
last,
put 36 twice.
but I said 8, right?
You did?
I did, I just didn't write it. And then the last one, 51 to 57 odd.
Nice.
In most cases, you'll have the odd problems. So we're going to start with number 21. If you choose to circle the number, that's totally up to you. I'm going to have 21 here. And then I'm going to write down the values that go with 21, which is 0.6 and 2/3. And you can do this if you want just on the number line paper that Mr. Long passed out, or you could do it on a piece of lined paper. That's totally up to you. But Mr. Long passed out to you paper with a number line. The only thing I ask that you do on your number line is label a couple of values. So you've got the number line drawn, you need to put some numbers underneath. So this is what my number line would look like. So the first value is 0.6. The second one is 2/3. Can somebody put 2/3 in the calculator and tell me what that is as a decimal? William, what'd you get at 2/3 as a decimal?
0.6 repeating.
0.6 repeating, which is 0.666666666666666, and eventually it turns to 7. So if I'm graphing 0.6, what two numbers is 0.6 in between? 0 and 1. Where would 0.66666 go? Yeah, literally right after it. So you've got like two values that are graphed right next to each other. They're so close. So that's all you're doing for 21. Done. Graph and you're done. So if you look at 25, actually what's 23? 23 is asking you to do the same thing. -7 divided by 2. And the square root of 7. So again, in your calculator, what is -7 divided by 2?
-3.5.
-3.5. And then how about the square root of 7, Brooke?
2.6.
2. So the first thing we need to do is take the numbers and get them into decimal form. And then either make yourself a number line or use the paper that Mr. Long distributed to you. So label the number line with a couple of values and then plot those points. So -3.5 is a little past -3, in between -3 and -4. 2.6, I'm going to 2, and then I'm going past 2. So if you look at 25, you're going to do exactly the same thing. Except the last part of 25 is then to compare the numbers. So after you graph them, which one is bigger than the other? Or which one is smaller than the other? Still have like 4 minutes. Maybe you could get 25 and 27. Let's see, maybe choose. But like you could start at -78 and then just go -76. Or you could count by 4s if you wanted to, like 4 tens, okay, 10 might be too big, maybe 5. Kind of like, depends on what you do. But if you could start at -80, Mom? Yeah, thanks for getting back.
Angelina, I'm awesome.